Hello. Welcome, everybody, whoever's here. We did in the last week also lots of stuff to do with statistics and mean, mode, median, and probability and stuff. Um, your homework on this, well, most of you did. If you were, a few of you were still on the physics cycle, so if you have questions on that, we can do that. But most people did this stuff on statistics. Um, And your homework wasn't that straightforward, so I'm expecting a few questions on here. Certainly the key stage 3 one, not so much on the other one. Um, look at one. Um, what do I do? I forgot my booklet in my bag, and my bag isn't here. I can't really help you with that. Um, just don't worry about it. Just try it when you get it. Um, 5, 6, 16, 17 in year 7, and then 10, 11 in booklet 1. MS3. I don't quite know what that means. Um, but I will, assuming that is booklet 1. Okay, Aston. Sorry, yeah, that's what it means. Yes, thanks. So yes, I think what I'll do is, given that quite a lot of questions from booklet 1 have been asked, I wanted to do most of it, for the time being. Let's have a look at it. Here it is. There's quite a lot of overlap in these questions across booklet 1 and 2, so I think, either way, I'll be doing quite a lot of them. I'll do the specific questions that have been asked first, if I can see them in order. 5, 6. There were some pretty difficult questions in here, I will warn you. So, a computer is going to choose a letter at random from an English book. The table shows the probabilities of the computer choosing each vowel. What is the probability they will not choose a vowel? Okay, so in the letters, there are vowels and there are consonants, right? This is showing you the probability of all the vowels individually. Now, for all of the vowels, if I said what's the probability of choosing a vowel, which could be A, E, I, O, or U, you would add all of these probabilities up. So I'm going to use a calculator here, and I would say that it's okay in this case if you do. Um, if you add all of those up, you will get the probability of choosing any vowel because A, E, I, O, U adds them all up and you get 0.39. But the question is not about choosing a vowel, it's about not choosing a vowel. In probability, the probability of all of the different options always adds up to one whole. So if the probability of me doing something is this, the probability of not doing it is one takeaway that. So in this case, that would be 1 minus that is 0.61, I believe. Okay, you see what other people are saying. Yeah, 16 and 17. I'll be getting to quite a lot of booklet 1. It's only booklet 1 that has been asked, so most of this will be done. Um, so that is how you do question 5. So it's about understanding that these are the probabilities of the vowels. The probability of the not being a vowel is 1 minus that. Okay, so if I said to you the probability of me winning a game is 0.7, the probability of not winning the game would be 0.3 because it needs to add up to one whole. Okay, right. That was question 5. 6 as well. Hannah went on a cycling holiday. Um, and this shows how far she cycled each day. On average, I cycled over 40 kilometers a day. Now, this is a little bit awkward question, this, because when we say, when this person is saying average, what they are referring to is the mean, which I know it doesn't say that in the question, but that is what it is getting at. It is getting at the mean. So what you need to do is calculate the mean of those four numbers. How do you calculate the mean? You add them all up and then divide by how many there are. Let's do that and use a calculator for it. So they all add up to that number. To get the mean, you divide that number by 4 and you get 39.9. So the average distance per day is 39.9. She says that I cycled over 40 kilometers a day. She did not. It was 39.9 on average. Booklet two, I will get to that. It'll take a little bit of time, but I will get there. Don't worry. Um, 5, 6, and then we also had 10, 11, and stuff. Question 10, let me see what this is. Um, Somebody threw three darts, and it says the lowest number was 10, the range was 10, and the mean was 15. What were the numbers? Well, if the lowest number is 10, one of them is a 10, isn't it? Obviously, I've already told you that. Range is highest number, take away lowest number. So if the highest number, take away lowest number is 10, and the lowest number is 10, then something take away 10 has to equal 10. That something has to be 20, because 20 take away 10 is 10. And then the last one, it says the mean was 15. It's a little bit harder, this bit, especially for you guys in year 7. But if I know the mean is 15, and I know that there are three numbers here, then I know that the three numbers have to add up to 15 times 3. They have to add up to 45, because then the way you got to 15 was by doing 45 divided by 3. So you sort of do that in reverse, and you get that they must add up to 45. So if I've got two of the numbers and they make 30, and they all need to make 45, the missing number must be 15. 11, right, that's A is quite easy. 11B. Right, once again, same principle as I said earlier. If you know the mean and you know how many numbers there are, so the mean is 5 and there's three numbers, you know that they must add up to 15, because that's the only way you'd do 15 divided by 3 and you'd get to 5. But I'll see if I can go through all of those. So a lot of these questions are overlapping, so they're in both booklets. So if you see a question that is on one of your booklets, then here you go. Right, it's just that some of them are overlapping a little bit in this um, in booklet one. They're not completely different, is what I'm saying. So you may come across a question in booklet one that is also in booklet two, and then there you go. And same with booklet three, possibly as well. Right. So as I said, these numbers, in order to have a mean of 5, have to add up to 15, because then you get 15 divided by 3, and that's where you get the 5 from. Okay, so I know that these have to add up to 15, and then it just says, what could the other numbers be? All you need is two numbers that add up to 13, because you've already got a 2, and I said that all of them have to add up to 15. So if you already got 2, then we could say, I don't know, 10 and 3. That would work, wouldn't it? They add up to 15, 10, 3, and 2. Or then it says, what else could the numbers be? Just choose two different things so that they still add up to 15, like 9 and 4. They still add up to 15, don't they? So as long as they add up to 15, that's what you're after. Okay. Okay, that's question 11B. Then we've got 14B, 15, 16, 17. Okay. That should be easy. That should be easy. Four numbers have a mean of 10. Once again, let's just understand this bit here. Quite a hard question, this one, actually. Four numbers have a mean of 10. If four numbers have a mean of 10, they must add up to 10 times 4. They must do. So these four numbers, whatever they're going to be, they will add up to 40, I promise you. The median is 10. Okay, that is a little bit awkward because the median is the middle number, but there isn't a middle number here because the middle is between two numbers. When the middle is between two numbers, what we do, the median would be the middle of those two numbers. So if the median needs to be 10, what I'm going to do is make that 11 and make that 9, because then then it's 10. The median is 10. Now what I need to do is make sure that all four numbers add up to 40. So far I've got 20. I'm not allowed to use 10, so I can't use sort of that. So what I might just do, just because I might just do 19 and 1. So now that's 19 add 1 is 20, add another 20 is 40. They add up to 40, which means the mean is 10, because you do 40 divided by 4. So the mean is 10, tick. The median is also 10 because it's between 9 and 11. And that could be the answer. Remember, you could choose other numbers here. You could have got 18 and 2. there's actually lots of possibilities here, but you need to make sure that your numbers add up to 40 and that the middle is 10. And that's the best way to do that is to put 9 and 11 either side of it. Okay, that would be that. We've also got now 15, 16, 17. 15. The median of these five numbers is 12. Write a set of four numbers that has a median of 12. So remember, like I said in the last question, when you have um, an even number of numbers, the median has to be in the middle of these two numbers. So if I need a median to be 12, the easiest thing to do here is to put, well, you could actually put 12 and 12 here, but you could do 11 and 13, because then the middle of 11 and 13 is 12. And then just pick two other numbers that like 9 and 14 or whatever. Or you could have 12 and 12 here as well. If they're both the same, the median is just in the is 12. Okay. Um, that would be that. And then 16, four numbers have a mean of 5 and a median of 5. The numbers are not integers. Wow. Right. Okay. If four numbers have a mean of 5, again, you get this a lot, so try and get the hang of it now. If I tell you how many numbers I've got and what their mean is, then I know what they add up to. They add up to 4 times 5. So they add up to 20. So I know that whatever these numbers are, they add up to 20. Okay, so we'll get to that in a minute. The median is 5, right? Give an example of what the four numbers could be. So none of the numbers are integers, and we need a median of 5. So I need like decimals here and stuff, which makes this a little bit harder. Um, I'll just tell you what the answer is. Quite a difficult question. Okay, if I pick those two numbers, right, 4.5 and 5.5, and I put them there, then their median, because it's in the middle of those, is 5. So I've satisfied this. Do you see what I mean? I've got a middle of 5. It's the middle of 4.5 and 5.5 is exactly 5. Um, and they're not integers. Integers means they're not whole numbers. Great. Then the other thing I need to do is make sure my numbers add up to 20. So far, they add up to 10. So I need another 10, right? So what I might do is choose 9.5 and a half. Because now all of these numbers, if you add them all up, add up to 20. 9.5 add a half is 10, and 4.5 add 5.5 is also 10. They add up to 20, which means the mean is 5, because you do 20 divided by 4, and the median is 5. That's a difficult question. Okay, so I understand why you have asked that question. And then that's all those ones done. And then 18 was the only other one before I move on. Oh, no, it wasn't. 17, sorry, 17. 17. You might not have got to this. This is called a stem and leaf diagram. It's my fault if you didn't get to it. A stem and leaf diagram is a strange thing. Okay. It is a weird way of presenting some numbers. I'll just tell you how you do it. Right. The idea of this is you're sort of making it's like a table, but it's a really, really weird table. Could it be sorry, can I scroll to question 15? Sorry, let me just do that first. There was question 15. Could it be 5.5, 5.5, 4.4, and 4.4? Don't think so, no, because it doesn't give you a median, sorry, that's not a median of 5. That's what we wanted, wasn't it? They also, I don't think they add up to 20 either. So no would be the answer to your question. It couldn't be those numbers. They don't add up to 20 for a start, but they need to. Um, and also the middle of those numbers, I don't think is 5. So I'd go with what I put. Right, the stem and leaf diagram. So I'll just tell you, once you see this, you'll never forget it. Okay, so The idea of a stem and leaf diagram is that you can put some numbers into a weird looking table where this line can be used to sort of create sort of abbreviations. So what I mean by that is, in this case, what we're going to do is imagine this side of the line is our tens column, and this side is where our units are going to go. So if I've got the number one, if we just put some zeros here in front of the single digit numbers, the tens column is 0, and then the units will go in here. Okay, so if I've got the number 1, for example, I'm going to put it there. If I've got another 1, you just put it next to it. So that suggests that I've got two ones, a 1 and then another 1. Okay, have I got any more ones? I've got another 1 there. Okay, done that. I've got some 2s. I've got 3 2s. You can see that, 3 2s. So I'm going to put all 3 of them there. I've also got a 4. So I'm going to put a 4 there. I've also got 2 8s. I'm going to put them there. I haven't put any of the other numbers here because they've got a different tens column, right? So now if I've got the number 19, that's tens is 1. It's got 110. So I'm going to put it in the second row because this 1 is telling me that there's a 10. If I want 19, I'm just going to put a 9 there. And that'll be it. I haven't put the others because they are all beginning with a 2. So to put 23, 27, and 26 into this table, I'm going to put a 3 there because that's now 23. I'm going to put a 6 next to it because that's 26. And I'm going to put a 7 next to that, and that's 27. That is a stem and leaf diagram. Okay, it's a bit useless, but that is what it is, where we are using this line to split up something. So in this case, tens and units. In other cases, it could have been hundreds and stuff, but in this case, it is tens and units because that's what the numbers are. It is also, I have deliberately done it as an ordered stem and leaf diagram. So I've made sure that these numbers are in order because that's the way I did it. Same with these numbers, they're in order. So they're in numerical order. One more thing you have to do in a stem and leaf diagram is explain what this line is doing by basically saying, well, this, for example, 1 and then 9 represents 19 broken biscuits. You can choose whatever you want here, like 2 and 3 if you want to have 23 there. It's fine, as long as you make it clear to the person reading it what this table means. And then part B, if the number of broken biscuits in one extra packet is counted, the median for all 14 packets is 5. How many biscuits are there in the extra packet? Ooh. Okay, so at the moment, the median, let me just figure out what the median is. How many numbers are there here? There are 13 packets, okay? So at the moment, there are 13 numbers here. The middle of 13 numbers is the 7th number because then there's 6 either side of it, if you see what I mean, right? And then that makes 13. So the 7th number is 1, 2, 3, 4, 5, 6, 7. At the moment, the median is 4. Okay, yeah, the median is 4 at the moment. When we have an extra number, then the median becomes the middle of the 7th and 8th number. And they said the median for all 14 packets now is 5. How many broken biscuits are there in the extra packet? I think the answer's got to be 6. Because then what you have is these numbers. You've got 1, 1, 1, 2, 2, 2. Let me explain this properly. So if I just write all the numbers out in order, 1, 1, 1, 2, 2, 2, 4, 8, 8, 19, 23, 26, and 27. Right. Before, the median was here because there are 7 numbers, no, 6 numbers either side of it. 6 numbers there and 6 numbers here. Okay. So 6 numbers either side of it. So that was the median. Now they're saying that we've added another packet of biscuits, and the median is now 5. So for the median to be 5, right, the only way for that to happen, because once you've got an even number of numbers now, 14 packets, the median's going to be between 2 numbers. So it's going to be like there, in the middle of 4 and whatever number is next to it. Now, if I put a 6 next to it there, the median becomes 5 because it's the middle of 4 and 6. And so the answer here has to be 5. Sorry, six. Because if we have six, then we put the median in the middle of four and six. Difficult question. Um, but challenge you sometimes. So where are we? 16 and 17 has been done, and 18 somebody asked as well. So 18 now is basically the same scenario. Now that you know what a stem and leaf diagram is, this should become easier. We have a stem and leaf diagram here, which is the amount of time people took to do their maths homework. So remember what this means. They've given you the key there. So somebody took 18 minutes, somebody took 19 minutes, somebody took 21, 22, 23, 23, 26. This was 30, this is 50, 54. So that's what this means. Okay, that's what these numbers mean. What was the longest time? Well, the longest time is this one here because it's 54 minutes. Okay. What length of time was the mode? The mode is the most common answer that you have. Now, what I'm looking for here is repeated values. So you see these here. I've got the number six there loads of times, more than anything else. So that's 26, remember, 26, 26, 26, 26. So that number seems to be there more than anything else. So I would say it's 26 minutes. The median, if there are 25 pupils in a class, just remember, if you need to find out where the middle is, and there's 25 people, or however many people there are, if you add one to this number and then half it, you will get the position of the median. So the median is the 13th number because 25 add 1 is 26 and half of 26 is 13. So the 13th number here is the median. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. The median is 32. It is the number in the middle if you had put them all in order. I wasn't in for a long time, spare booklet. Do I need to do my notes? I mean, that's really up to you. I'm going to leave that up to your discretion, as to what you feel is best to do. You do have everybody does have a test coming up on recent topics. So it would be advisable to do some notes on the topics, so that you learn stuff in anticipation for the test. In my opinion, the best form of learning is to do the notes, because that's where you actually are retaining the information that we do. Right, I think that's all of the questions on booklet one at least. Um, Somebody asked me 8 on booklet 2. I'll check if that's already been done. If not, I'll move on to booklet 3. No, it has not been done. Right, quite a complicated question, this. Um, right, there are 5 people in the Smith family. Mrs. Smith, Tina Smith, Helen Smith, Mr. Smith, and Ben Smith. The mean age of the males is 28. Right, again, I've seen this, you've seen this quite a lot now, where if I tell you what the mean is, um, booklet, sorry, I'm just going to just have a look at what question 19 is on booklet 1, sorry, just so I can move on from it. Do I need to do question 19? Which temperature was the mode? Is the number that's the most common here. So you have to look through this and see if it should repeat. Is any repeated? 6 looks to be repeated here, more than once. In a different city, the temperature was 5 degrees C lower than in Moscow. So in Moscow, it was 2, 5 degrees C lower than that. You take away 5 from that number. That is question 19. Done. You go back to that. So, if I tell you that there are 2 people and the mean is 28, then you know that their ages add up to 28 times 2, which is 56. That's the only way their mean could end up being 28, because you do 56 divided by 2 to get their mean. So I don't know how old Mr. Smith and Ben Smith are, but I do know that their ages add up to 56. Okay. The question is, what is the mean age of all 5 people? How do you find the mean age of all 5 people? You add up their individual ages, 38, add 9, add 7. Now, I don't know how old Mr. Smith and Ben Smith are, but I do know that their ages add up to 56. That's all I need. I don't need to know them individually. I just need to know that they add up to 56. So I can then add that on to everybody else, get my total, and divide it by how many people there are. There are 5 people in this family. So you would do 38, add 9, add 7. add Mr. Smith and Ben Smith, which add up to 56, and divide the answer by 5, and you would get 22 as your mean. Right. That looks like that is done. And then on booklet 3, specifically, you asked 4B. I know somebody else asked a lot of questions on it. We'll have a look at them. Um, this is 4B. I've got a bad feeling about some of these questions. I've got a feeling I remember all these from like a year ago, but I remember that sometimes there are the odd mistakes in some of these. Um, the pie chart shows information about how year 10 students travel to school. Oh, sorry, 6B. Apologies. On the wrong question. Oh, no, you said 4B and 6. Which one do you want? Both of them? Or okay. Right. I'm going to do both of them. 4B. Um, both. All right, sure. 4. Let me read it first. The pie chart shows information how year 10 students travel to school. Okay, walk, cycle, car. I've got a feeling there's an impossibility in this. A student from year 10 are chosen at random. Mark with a letter the probability of each of the following. The student walks to school. Walking is a quarter, so that is why that is A. The student does not walk to school. That must be everything else, which is 3/4, which is there. Travels by train. Well, there is no train in here, which means the probability is 0. 40 students travel by car. How many year 10 students are there? See, I don't think you can do this without some sort of measurement. Yeah, I just don't think you can. So I think the way to do this question, or the only way to do this question, is actually to measure that angle. Okay. So this angle, if you do measure it, which you can use a protractor to measure it, turns out to be 60 degrees. 60 degrees out of the total is 360 degrees, is a sixth of it, which means 1/6 of everybody travels by car. Okay. Um, no, sorry, that's not right. Yeah, 1/6 of everybody travels by car, and they've told you that that is 40 people. So if 1/6 of everybody is 40 people, isn't everybody 6 times that? That's 240 people altogether here. Because 1/6 of them, which is 40, which is 60 degrees out of 360, is 40 people. And then, well, no, you didn't ask me that, so I won't do it. 6. The table shows the proportion of left-handed and right-handed students in a school. Okay. 20 boys and 10 girls are chosen at random. Estimate the noise level. That should be easy enough. 6B. So, right. I think the only way to do this is to go, if you're a boy, the probability of being right-handed is 85% or 0.85. If you're a girl, the probability of being right-handed is 88%. Oh no, I've got it. No, let me do that again. It's a quite hard question, I think. So let me just check if this is matches my thought process matches the answer. Yes, it does. Okay, right. Right, this is the way you have to think of this question. It's quite a complicated question, but the February the 7th online. Sorry, I'm listening, reading what somebody says. Um, no, at the moment, no, mainly because it's a long way away. But what you could do is go back to our YouTube and find the session I did around that week, and I will probably have done some of the questions from the booklet then. Right, what you have to do in this question is think about the fact that there's two ways in which of getting a student that is right-handed. You could have a boy, so you're going to pick somebody, right? Imagine this is who you pick. This could be a boy who is right-handed, or it could be a girl who is right-handed. Because there is an equal number of boys and girls, the probability of picking a boy is a half, right? Because it's equal number. That's the probability of picking a boy. The probability of that boy being right-handed is 0.85 or 85%. So the probability of getting a right-handed boy is 0.5, so getting a boy first, and then them being right-handed is 0.425. For a girl, again, the probability of picking a girl is a half, and them being right-handed is 88%. So what you do is you multiply those together to be girl and right-handed, which is 0.44. But then you could get either of these. The question is, the student is right-handed. There could be a boy who's right-handed, or they could be a girl that's right-handed. So you add their two probabilities together, and you get 0.865. Or just, yeah, that's enough. That would be the answer to quite a complicated question, I admit. Right. Let me see what else there was here. I'm not going to do all of these, the ones that you have asked, but the thing to remember with questions like this is that if you know the mean, which you do, and you know how many people there are, you know what everything added up to, because you would do 82 times 19 in this case. So if you imagine all of these hockey players, if you added up all of their weights, they would add up to 1,558. That's how you got a mean of 82, because you do that divided by 19. Now, somebody joins the squad who weighs 93 kg. The question is, what is the mean mass of the squad now? Well, the whole squad is now 20 people, so we're going to divide by 20. The total mass is what the 19 were, plus the extra person, which is 93, which is 1651. If you divide that, you can use a calculator, no problem. You get 82.55, which should be the answer to that question. Um, this question, what fraction of the 20 children are right-handed? Well, right-handed is these 15 people out of 20. Simplify it, 3/4. What's the probability the child is a girl? How many girls do you have here? 9 out of 20. I think that's it. Let's see some of the other questions here. 8, A, B. Not going to do all of them. Did 4, B. With 5, I think this is an important question to get right. If you have to work out an estimate of the mean from a table that looks like this, you need to remember midpoints first. When you have a group of information here, we don't know the time for these three people. We just know they're somewhere between 30 and 32. So what you do with all of these situations is you go to the middle and pretend that all of them actually took the middle amount of time. So 31, 33, 35, and 37. That is the middle of all of these groups. Then you can forget about this. Then what you need to do is what you're trying to do to get a mean is you're trying to add them all up and divide by how many there are. How many there are is the sum of this column, which is 20. And then to add them all up quickly, imagine you had 31, 3 31s. How would you add them up? You times them together. If you had 9 33s, you times them, you times them. You then get new numbers here, use your calculator, add up this number, that's what everything adds up to, and then divide it by 20. That's how you would get the mean from what's called a grouped frequency table. Um, And then I might just do one more. 9B, 10. That'll be the same. If you can understand what I did here, then these are all the same questions, right? So you get to the middle of these groups. If you're not sure how to get to the middle of two numbers, add them together and divide by 2. So the middle of 5 and 15 is 10. Put the middles there. 15 and 25 will be 20. That'll be 30. That'll be 40. And that'll be 50. So now forget about these. We need to add up everything, but there's 14 tens and 12 20s and 11 30s. So you need to times them together, add all of these up to get to this number here, and then divide that number by how many well there were in total, which is 40. So that hopefully makes sense with regards to those questions. And I think, given that there are no further questions on that, I think that will be enough of a hand on that booklet because they're quite repetitive once you get to the last few. Right, I will stop for 9 minutes and then I will return to assist anybody. It won't take long actually for year 10 and year 11 because it's quite easy and it was the same for both of them, I think, which is speeds things up for me. So yes, I will return shortly. Um, yeah, booklet 3, does that say 10A? I don't know if that says 10A. I think I just explained that, which was um, the same scenario as the previous two examples that I just mentioned, which is you work out the midpoint of your group, which is the middle of those. You can ignore that one because it's 0. Write down the middle of the groups, times those across, add up these numbers. Once you get to this number here, you divide that by how many there are, which is the sum of this column, which is what? 40, I think. Divide by 40. That's how you work out the mean in that situation. So they are all basically the same question 3 times. Right, I'll be back shortly. Hello, welcome. Um, I'll go straight to question 9 first, given that's the one that has been asked. But then I might just go through most of this, because I don't think there'll be many questions, and because I think the two were the same for 10 and 11 this week. Fine, fine, yeah. Right. Joanne has a fair five-sided spinner. Write down the probability of scoring a 4 with one spin. Well, that's going to be 1 out of 1, 2, 3, 4, 5. That'll be that, firstly. The more complicated question, I suspect, is the next one. Work out the probability of scoring a total of 4 with two spins. Okay. First thing to do with any probability question that's remotely complicated like this one is write down how you could get what they are asking you for in the question. So they're asking you to get a total of 4. How could you get that with two spins? Well, you could get a 1 with your first spin, followed by a 3. That would be a total of 4. Or you could get a 3 with your first spin, followed by a 1. That's a total of 4. Or you could get a 2 with your first spin and a 2 with your second spin. That is also a total of 4. They are, from my reckoning, the only ways in which you could get a total of 4 here. They are the only ways. You could get a 1 then a 3 then a 1, or a 2 then a 2. Right, that's the only way to do it. And so what you need to do now is work out the probability of each of these things happening. So to get a 1 and then a 3, the probability of getting a 1 the first time is 1 out of 5. And then the probability of getting a 3 after that is also 1 out of 5 because there's only 1, 1, and 1, 3. For both of these things to happen, you multiply them together. Okay, that is, if you multiply them together, 1 out of 25. Okay, then we move on to a 3 and then a 1. That's just going to be the same thing again, isn't it? Because the getting a 3 is 1 out of 5, and getting a 1 is 1 out of 5. Times them together, that is 1 out of 25. Then, to get a 2 and then a 2, to get a 2 with your first spin, because there's two of them, the probability of getting a 2 is 2 out of 5. Then when you spin again and you need to get another 2, again, the probability is still 2 out of 5. You times them together to get the probability of getting a 2 and then a 2, which is 4 out of 25. When you have lots of ways of doing what they want you to do, in this case, getting a total of 4, you add the probabilities together. So I'm going to add all of these together to get 6 out of 25. And that is the answer to that question. I'm going to make sure that is the answer to that question. Yes, it is. Right, what I'll do, given that there isn't much else going on in this one, and I also appreciate quite a lot of people weren't here this weekend and stuff, so you might not have done some of this. I will start just to briefly go through most of this. The scatter graph shows the best high jump and the best long jump for 15 boys. Write down the correlation. Correlation, we generally say things like positive and negative or strong and weak. It's only one mark, so just a positive correlation is fine. You can say strong positive if you like, but the word positive is necessary. When it goes this way, it's positive. If it was going this way, generally it is a negative correlation. Liam has a best high jump of 166. Use a line of best fit. So a line of best fit, use a ruler. I could use a ruler. Yeah. Roughly, just split these in half. Okay, so you've got a line of best fit. And then, if you have a best high jump of 166, estimate his best long jump. So go to 166 on the high jump, which is there, straight up until you hit your line, and then go across until you get to your long jump, which is about 532 roughly. I think you have a range of answers in this kind of question usually. So let me see what it says. Yeah, as long as you read off your line of best fit correctly, it's fine. Another boy has a best high jump of 195. Why should you not use a line of best fit? Because your data only goes up to 185. You see, that's the last value. You don't have any data around here where 195 would be. So you can't just assume that it carries on going in a straight line. You have to stick with the bits that you have. So that's why you should not do that. Um, Faye is testing an ordinary six-sided dice to see if it is biased. She throws the dice 120 times. Work out the number of times you expect to land on a one. Well, the probability of landing on a one on a dice is 1 out of 6. Got a question? Yes, I'll get to that. So the probability of getting a one once is 1 out of 6. If you're doing it 120 times, you times the probability of doing it by how many times you're doing it. 1/6 of 120 is 20. Is the dice biased if these are your actual results? I would say yes, because if I roll the dice 120 times, I would expect to get around 20 sixes. Or well, all of them should be about 20. Should be about 20, 20, 20, 20, 20, 20, roughly. Not exactly, but roughly closer to 20. And that's quite far. So my reasoning, is that the next question to explain it? No, it doesn't. It just says tick a box. So yeah, fine. Um, I think it meant to give a reason, but I don't know why it just said that. No, just yeah, apparently meant to give a reason. So you'd expect the one number to be a bit higher or that one to be a bit lower. Let me just do the question that has been asked, which is 4C. This won't go on for the full hour this time because I know that there's not going to be many questions on this. Um, Right, I'll have to do all of this. Here is some information about a test. Cumulative frequency requires you to kind of add up as you go along. So you have 20 there, but then the next one is 48 because you add these two together. The next one will be all of these three added together, which is 88. And then all of these ones added together, which is 118. And then all of them added together, which is 100, no, 108 even. Um, all of them added together, which is 120. Um, Yeah, so that's that. That's the first bit done. Then you would plot your graph, where you plot this number with this number. So if I just roughly do this, 10 and 20 is about there, 20 and 48. Okay, your graph will look, it's not, it should be a curve, by the way, not a straight line. And then once you've done that, students who scored 15 marks or fewer take another test. Estimate how many students should take another test. So we need to figure out how many people scored 15 or fewer marks. So if you go to 15 on here, which is there, and read up, you get to how many students scored 15 marks or fewer, which is what? About 30, but it's probably more precise, 24, 28, 32, roughly. So I would go with an estimate of 32 for that one. Yeah, so as long as you read up from 15 and then read across, that's what you want to be able to do. I'll do this one because there's a weird part of this. A company makes bags of toffees. Write down the mode. The mode is whichever number appears more than the most. So is that 50? Is it? Oh, it's 51 maybe. One, two, three, four, five. And then one, two, three, four. So 51 is the mode, not 50. There's more 51s than anything else. Work out the median. To do this, you're going to have to put these numbers in order first. Just be really careful when you're doing this. So the lowest number is 43. Just cross it out as you go. Then we've got one, two, three, four 50s. Then we've got one, two, three, four, five 51s. then we've got a 52. And since there are 11 bags here, the middle is the sixth bag. If you're not sure about that, add 1 to this number and then divide by 2. 12 divided by 2 is 6. So the sixth number is the median. 1, 2, 3, 4, 5, 6. Because there are now 5 either side of it. Work out the mean. Ugh. Add them all up and divide by 11. Let's do it quickly. That's what I could do is 43 plus 50 times plus 51 times 5 plus 52. I think it adds up to 550. And there's 11 of them. 550 divided by 11 is 50. Okay, the reason I did all that was for this next question. The company claims there are 50 toffees in a bag. Why does this seem fair? Well, because the mean is 50. Fine, so that seems fair enough. Why does this claim seem unfair? But then you could say, because remember, the mean, mode, and the median are different ways of expressing an average kind of thing. Okay, so there's no one correct way to do it. If we use the mean, then there are 50 toffees in the bag. Okay, but if we use the mode or the median, it's 51. So you could say that this is wrong because both the mode and the median are 51. So you could say that. Okay. And then the company uses the first 11 bags produced each Monday to check the content. So what they're doing is that the machine is producing all of these bags of sweets or whatever they are. And they're checking them, but they're checking them the first 11 bags every Monday. Couldn't we improve this by checking more bags for a start? Why only 11? Why not check 50 bags and then check the contents and see if that works? Why only the first 11 bags? Why not choose 11 bags but spread them out a little bit more? And why only each Monday? Why not check it on throughout the week? So these are the ways in which you can improve this kind of investigation. A box plot, which you might have got to. 1B. Did I do that? 1B? Isn't this question 1B? I'm just checking if you've got the same one here. I don't know. I don't know about how would you word it. Use a line of best way to estimate his best long jump. You would. I'm losing my voice again. You draw a line of best fit, then read up from his high jump until you hit the line and read across to your long jump. Thought so. 2B. 2B is the dice by. I would word it as saying that you would expect the number of sixes to be lower or the number of ones to be higher. I think that's the issue here, that these should be closer to 20. So you could say either the number of sixes should be lower or the number of ones should be higher, or both. I'll say both. You'd expect all of them to be closer to 20, something like that. So I'd word it. Question 6 has popped out. Right. This is the same as that other one, really. So when you do cumulative frequency, you need to make sure that you make another column for cumulative frequency. Cumulative means add up as you go along. So we start with the same number here, but then subsequently we add up everything from before. So that's 9 again, because it's 9 adds 0. But then you add 9 to this 35 to get 44. Then you add on the 30 as well to get 74. Then you add on the 18 to get 92. And then you add on the 8 to get 100. So in the end, you counted everything, basically. That's the point of that. Sorry, yes, I did foresee. So once you've drawn I'll just quickly go back to this, sorry. Once you have drawn the cumulative frequency graph, 15 marks or fewer, you go to 15 on your axis there, read up and read across. And what that tells you is that about, whatever that is, it's about 32 on mine, 32 people scored 15 or fewer marks. In other words, this section of the line is about 32 students, and everybody else is above that. So 32, what you do. Or whatever your graph says. As long as you read up correctly from your graph and across, then you're fine. Back to this. Once you have got these cumulative frequency columns, on your graph, you plot this number with the upper value. That's really important that you get the upper value of your data. So I'll have to do this sort of like this, very, very roughly. So 0 with 8t. So 80 with 0. Oh, that's really strange. Okay, 100 with 9. 120 with 44. I'm doing this very, very roughly because I don't want to zoom in. 140 with 74 will be about that. And 160 with 92 will be about there. And 100 with 180 will be about... to get a very weird looking one here. Generally, cumulative frequency should look like S shapes. Let me just finish off this question and I'll see what somebody has asked. Estimate the number of these films with a running time of less than 2.5 hours. Very similar to the earlier one that I was doing. 2.5 hours is what in minutes? It is 150. 150 minutes. So what I need to do is read up from 150 and across. 150 is roughly there. Oh, God. Use a ruler. And straight across. And that will be the value that you want here because that's many are sort of less than 150 or 150 minutes. And then the ones beyond that are above it. That was 6B. Sorry, that was the one I was doing. Seems to be done. Histograms, I think, are worth talking about to do this question because they are different. The difficulty with this whole topic, by the way, is the slightly different thing you do every time depending on what the question is. So sometimes, if I've been asked the mean from a table like this, I use the midpoints and I times by the frequency and I add up and divide by how many there are. If I'm doing cumulative frequency, I make a cumulative frequency column like we did before. If I'm doing a histogram, I find something called frequency density, which is the frequency divided by the width of the group. Okay, so what I like to do, just when I'm teaching it certainly, is go, okay, well, what's the width of each of these groups? Well, that's 0 to 2, so 2. That's 2 to 3, so it's 1. That's 3 to 4, so it's 1. 4 to 5 is 1. 5 to 7 is 2. 7 to 10 is 3. And so my frequency density is just this divided by this. So 8 divided by 2 is 4, 13 divided by 1 is 13, can't do this one, 19, can't do this one, 15 divided by 3 is 5. And so I've got some frequency densities, but as it turns out, I actually have got the frequency density for the other one as well because I've got the bars drawn. You could, if you really wanted to, not that you really need to, is note down the frequency density of the bars that we didn't have here. So you could say that, well, this 3 to 4 has a frequency density of whatever that is. What is that? 17. You could say that the 5 to 7 bar has a frequency density of 14 if you read across. Okay, the reason that is important is because the other important part of this formula is that if I wanted the frequency, which is how many people there are, then if you rearrange this equation, the frequency density times the width is the frequency. So if I want to know what goes in here, it is just frequency density times the width. 17 times 1, 17. 14 times 2, 28. You see what I mean? So I've kind of completed everything. I've completed the table. I suspect I need to complete the histogram now. Well, it says use the table to complete the histogram, and then it says use the histogram to complete the table. So I've done the table. To complete the histogram, I need to draw the remaining bars here. And so the 2 to 3 bar goes up to 13. Remember, on this axis, we have frequency density, not frequency, and that's what makes it confusing. So I need to have a bar that goes from 2 to 3, but goes up to 13. Something like that. Okay. And then the other bar, 4 to 5, goes up to 19. So something like that. And still another bar, 7 to 10, which goes up to 5. Now, this is 7 to 10, so it's a wider bar, and it goes up to 5, so it would look like that. The thing about histograms is that the area of the bar represents how many people are in the bar. So it's not just the height of the bar, it's the height times the width of the bar. So if you take the width of here, it is a width of 3 and a height of 5. 3 times 5 is 15. And so that area is telling me how many people are in that group. Cumulative frequency, you always use the higher value because I'll just give you some context to that. Ultimately, what you're doing here, just so you understand, this number 0, this cumulative frequency, is telling me all of the films, because that's the context here, that are less than 80 minutes long. So none, right? This number is telling me all of the films that are less than 100 minutes long, which is these 9 and the 0 before it. These 44 are all the films that are less than 120 long, which is these 35 and these 9 and these 0. Do you see what I mean? So these numbers are corresponding to the upper value of the group because they're telling me how many are in total, how many are up to that number? So up to 160, there's all of the ones above. So that's why it's the upper value of the group every time. Um, Anything else? Gee, that's awkward. Um, right, I think there's a tricky question. I'm going to do this. Question 8. Anna plays a game with an ordinary fair dice. If she rolls a 1, she wins. If she rolls 2 or 3, she loses. If she rolls 4, 5, or 6, she rolls again. When she has to roll an odd, so we're talking about an ordinary fair dice here. Um, when she has to roll again, okay, fine. Complete the T diagram. So if she rolls a 1, she wins. The probability of rolling a 1 on a dice is 1 out of 6. A 2 or a 3, because there's 2 of them, is 2 out of 6. You can simplify it, but I'm not going to. And 4, 5, or 6 are 3 out of 6, which has been simplified to a half. Fine. Um, then it says that if you roll a 4, 5, or 6, you roll again. That's why we've only got these here, not here as well, because you're not rolling again unless you go down this path. If you roll an odd number, you win. If you roll an odd even number, you lose. And the probability of an odd or even on a dice, because there's half and half, is half and half. Now the question is Anna more likely to win or to lose? Right. You must work out the probability she wins. Okay, so let's work out the probability of winning. How can we win? We could do it over here. We could just roll a 1 straight away, right? Or we could roll a 4, 5, or 6 and then roll an odd number. Do you see what I mean? So the two ways of winning are either you go that way or you go this way. So they're the two ways in which you win in this game. So you could just roll one that straight away. That's one of your probabilities. Or you could roll a 4, 5, or 6, the probability of which is a half, and then roll an odd number, which is another half. So this bit here is a quarter to which you have to add the probability that you could have just won immediately. So there's two ways of doing it. Either you roll a 1 straight away, which is 1/6, or you roll a 4, 5, or 6, and then an odd number. That's a half times a half. 1/6 plus 1/4 is what you have to do, which is 10 over 24. Easy way to do that. 12, isn't it? It's easier. 5 over 12. So 5/12 is the probability of winning. Is she more likely to win or to lose? Well, if the probability of winning is 5/12ths, then losing is 7/12ths because it has to add up to one whole. So you are more likely to lose because 7/12ths is bigger than 5/12ths. That's it. Did that. Let's fill some of these in for you. Probability of rolling a 4 is 1/6. Not 4 is therefore 5/6 because there's five other numbers on the dice. What question? If we do a question I sent to you. Um, Let me have a look at it first. Let me finish this question off and I'll have a look. Second spin is the same scenarios, so that and that, that and that. Probability of landing on dice 4 both times, you multiply those two together. Right, let me finish off. I think, as I say, it's going to be a bit short because I think everybody had the same homework and there's not many questions. Eugh, it's horrible. Um, so these questions, yes. Yes, I'll do those. I don't know about the second one. Um, So I've got coming up a histogram question. The thing with histograms sometimes is unlike this question here. Sometimes they don't give you the scales on the axes, and that can make it feel a bit more complicated, as per the question I'm about to do. Okay, so they've asked you to draw a histogram. As you can see, the histogram below doesn't have any, ignore the mouse cursor there, doesn't have any numbers on the left-hand side. Okay, so first things first, if I see a histogram, the words that spring to my mind are frequency density. Frequency density is frequency divided by the width of the group. Let's write down the width of the group just quickly to make sure we don't get this wrong. That's a width of 5. That's also 5. That's also 5. That's 5. That's 10. And that's 20. Be very careful. Um, and then frequency density is this number divided by this number. 35 divided by 5 is 7. 42 divided by 5 is 8.4 probably. 20 divided by 5 is 4. 18 divided by 5 is 3.6. 14 divided by 10 is 1.4. And 11 divided by 20 is 0.55. Use a calculator. I should already check those. I'm fairly confident in my abilities. Um, yeah. Yep, fine. So frequency density, that's what they are. We need to draw all of these on the histogram. So first things I need to do is I need to figure out, this is very hard to see, the printing isn't fantastic here. I need to figure out what my scale is going to be on the left-hand side. So it goes up to 8.4, right? As you can see, there's an 8.4. That's the biggest number I've got. Everything else is smaller. So I need to make sure I've got at least 8.4 covered on this axis. Oh, Jesus, this is absolutely horrible. Because we don't even have the thick lines here, do we? I'm going to go to, no, that's not going to be big enough. Hmm. Okay, just about. There you go. I can get nine on there, going up five little squares at a time. As I say, you'll have a slightly easier situation because you get the thick lines, and I can't see any of the thick lines on here. Um, so one, two, three, four, five, six, seven, eight, nine. Right. Now I need to basically just do it. So I need a bar from 0 to 5. So that's 0 to 5. That's the width of this first bar. It goes up to 7. I'm going to do quite roughly this. Okay. 5 to 10 is another bar that goes up to 8.4. 8.4 is roughly there. Okay. 10 to 15 goes up to 4 on the frequency density. Oops. So roughly like that. They're all the same width because they're all a width of 5, as is the next one. 15 to 20 is to 3.6. It's about there. Again, I'm doing it again quite roughly here. The next bar will be wider because it goes from 20 to 30 and it goes up to 1.4. There you go, wider bar. And then 30 to 50 is the widest bar and it goes up to 0.55, which is about there. And that is a histogram. Done. Um, yeah, yeah, that's what you do. And I'll do one more question, which I don't know. This is nothing to do with what we're doing today, but let me see what's going on. I don't know if I need part A for this question to make it make sense. Yeah, I'm pretty sure I do. Um, yeah, I don't think I can do this without part A. I think part A will tell me some information about what people spend in the shops. Yeah, okay. On the basis that I don't, I'll see if you can send it to me in the next minute. But I don't think I can do this without knowing more information about um whatever part A would have been. Oh, is the histogram part A? Oh, I'm so sorry. Yeah, it is. Oh, jeez. Sorry. I just thought they were completely separate questions. Right, that's fine. That helps. I didn't even read the question. Right. Anna records the amount of money spent by 140 customers in a shop on one day. Um, so no, it is part. Yeah, so it's the same question. Sorry, I just didn't think about it. I didn't read the question properly. I just did the histogram. Um, Say 10% we spend more than. So she wants to give the discount to approximately 25% of her customers. Okay, so I would just, I mean, it's just a justification, isn't it? So I would say that, look, there are 140 customers here. Um, and this is the amount of money they spend in the shop, right? From 0 to that. Now, it's fairly evenly split, 5, 10, 15, 20, and then that, right? Fine. Fine. So what I would say is that if I go into so I want to try and give a discount to about a quarter of my customers, right? So I need to find out the quarter that spend the most, okay? So if you imagine my customers in a list, right? I want to give my discount only to these people who spend the sort of most money. And so what I'm going to do is find out roughly where three quarters of my, or what value is at roughly three quarters of my data. So there's 140 customers. Three quarters of that is 105. Now let's figure out roughly where how much the 105th customer spends. So I've got 35 here and then 42, so that's 35, 77. Then another 20, that's 97. And so the three quarters is about in here somewhere, right? So about three quarters of my group spend less than 15 to 20 pounds, and about a quarter of them spend um sort of 20 to 30 or 20 to 50 pounds, right? So I would probably just go with about 20 pounds and say, and my justification would be that if you make it at 20 pounds, then roughly a quarter of people, which is out of 140, 35, um, spend um, more than £20, basically. And about three quarters spend less. That's it. I don't think there's any right answer to this as long as you justify it sensibly. So a suitable amount of money would be about £20 because based on this data, about a quarter of people spend more than £20 and about three quarters spend less. Look, see, these numbers are really like there's a lot more people here that spend sort of lower amounts of money, and there's fewer people that spend higher amounts of money. So about £20 is it seems to be the sort of fair one. I don't think there'd be a wrong answer to this as long as it was you explained that that's what you're looking for. Right. I don't think there is any more to do. Next week, on the weekend at least, you are actually doing some more maths stuff because we're still at the end of the month. It's a bit complicated, our schedule. So there'll be a sort of maths revision kind of thing. For the year 10s, year 11s, we'll probably have some sort of papers and stuff for homework, which will be good revision. So we'll be doing a bit more maths this weekend. And then I'll be back to biology and chemistry and stuff the week after that. So I think that's enough for